Section 12.3, we're going to look at surface areas now of pyramids and cones. So that's what we're going to work on, and we'll kind of show you where those formulas that we're going to use come from. But let's just quickly review, remember what a pyramid is. Remember, it's a polyhedron because it's made up of faces, edges, and vertices. The base is always a polygon, and the lateral faces are triangles with a common vertex. Now, a lot of the ones that we are going to be calculating surface area for would be regular pyramids. So that means the base is a regular polygon, and the lateral faces will be congruent isosceles triangles. So keep that in mind as we move forward through this. So again, looking at a net of a regular pentagonal pyramid, remember, regular means that all the sides on that base are the same. And if we are going to calculate the surface area, okay, we would find the area of this base, and that is a regular pentagon. Then we would find the area of one of these triangles, and then we could multiply it by 5. Okay, so if we look at one of these triangles, remember the area of the triangle will be 1/2 the base of the triangle times the height of the triangle. Well, the base of the triangle is 11.62, and the height of the triangle is the height of one of those triangles is actually called the slant height. And so that is 17. So if you look at this height right here, that is the height of one of those triangles, and it is actually called the slant height. So if we find the area of one of these, that would be 98.77, and then we just multiply that by 5, which gives us 493.85 units squared. That's the area of all the triangles. Then if we work on finding the area of the regular polygon, that formula of that pentagon formula is 1/2 the apothem times the perimeter. Well, the apothem is this piece right here, so that is 8, and the perimeter is 11.62 times 5. And then we'll just add those together. This gives us 232.4 units squared. So now when I add these numbers together, that gives me the total surface area. So 232.4 and 493.85 would give us a surface area of 726.25 units squared. Okay, so this is how we can calculate it using a net. But again, notice that this right here is the perimeter, and that's just 17 times 5. Oh, sorry, not 17. That's the 11.62 times the 5. Okay, so that's just the perimeter right there. And so our formula looks similar to what we've calculated before. We can take the perimeter, the base, times the slant height, and that 1/2 of that finds the areas of all of the triangles combined. And so when we look at that formula, we have the surface area equals the area of the base plus 1/2 the perimeter times the slant height. Okay, and that is the formula we use. Notice there's only one capital B because there's only one base. And again, this slant height right here usually is a scripted L. You can see it over here. That is the slant height. And that is the height of any of one of those congruent isosceles triangles. And the lateral areas is the area of all of the triangles. And that's what calculates that. And then you have to insert whatever base you have, the formula for that base. So let's try one. says find the area of each lateral face of the regular pyramid. So we actually are only going to find one of these faces. That's all they're asking us to do in this problem. Notice you have a height. This is the height of the actual triangle. It's not the slant height. So if I'm finding the area of one of those faces, you have 1/2 the base times the height, which is my slant height. So this is what I'm going to need to find. I already have the base is 22. So I can take 1/2 times 22, but now I need to work on finding that. And if you notice here, we do have this height is perpendicular and it goes out here. And so what happens with this is this is also right angle, so we can actually use the Pythagorean theorem to find that slant height. Remember, this is going from the center out, so that's going to be 11, and this is going to be 18. So now using the Pythagorean theorem, finding our slant height, we would have 18 squared plus 11 squared equals slant height squared. So our slant height is approximately 21.1. So we put it in here. And then we can calculate one of those triangles. The area is 232.1 centimeters squared. Okay, so that one was just finding one. This is going to find the total surface area and lateral area. So let's start by writing the formula just for practice. We have our surface area is equal to the area of the base. Remember, there's only one, and that's our capital B, plus 1/2 the perimeter times the slant height. All right, so now fill in what things you know and see what things you're going to need to find. Well, it is a regular pyramid, so all of the sides are 5. So I can fill in the perimeter is 5 plus 5 plus 5, or 15. I also am given my slant height of 7.5. So that is going to be my lateral area here. And so my lateral area is 56.25. So now let's go back and see what we have for our base. Our base is this regular triangle. So my formula for calculating that is a triangle formula. It is 1/2 the base of the triangle, which I know is 5, and now I need to work on the height of the triangle, which I don't know. So what I am trying to do, if I redraw this triangle right here down below, I know this is 5. I am trying to find this. It's equilateral, so again we have our 60-degree angles, and then this cut 1/2 is 30. The whole length is 5, so that makes this 2.5, just that piece. So now I can use my relationships. My short leg is x, my hypotenuse is 2x, and my longer leg is x root 3. So that means that this height of the triangle is 2.5 square root of 3. So the area of my base is 10.83. And when I add that with my 56.25, that gives me a combined surface area of 67.08 units squared. So we have another similar one here where we have a regular pyramid, has an octagonal base with a base edge length of 8 and a slant height of 12. And this one's a bit more complicated because you're going to have to use some trig. And what I like to do is, start by writing the formula. Surface area equals the area of the base, which is an octagon, plus 1/2 the perimeter of the base times the slant height. Okay, it told me the slant height was 12. So slant height of 12 yards, I can put a 12 in there. It's regular, so my perimeter is 8 times 8. So I have all of my lateral area right there, and that is actually 384. So now let's work on the area of the base. Well, the base is a regular polygon, so that means my base is 1/2 the apothem times the perimeter. That's what I'm going to need to calculate for my surface area. So let's look at the octagon. Not the best drawing, but that's okay. We know that this side is 8, okay? So what we need to find is that apothem, which is the height of one of those congruent isosceles triangles. So if I redraw this out here, I have this piece of it is 4, and I am trying to find this. Now, if I take 360 and I divide it by 8, that gives me 45 degrees for the whole angle. So now I need to cut it in half, so that makes this degree right here 22.5. So now if I look at the opposite over adjacent, I can do the tangent of 22.5 and set it equal to the side opposite divided by the adjacent. And now when I solve, I'm going to multiply each side by a. And then I'm going to have, that would give me a times the tangent of 22.5 equals 4. So now I'm going to have to take 4 and divide it by the tangent of 22.5. So that gives me a value of a of approximately 7.17. So now I can put that in here. So my surface area is equal to 1/2. The apothem, which I just found, is 7.17 times the perimeter, again, which is 64. And that gives me a total of 230 added with the 384 gives me a surface area then of 614 yards squared. So again, you're going to have to go back and use some of the things you already know about regular polygons. Those are the tricky parts. So let's move on to cones. So cones are not polyhedron, okay? They're kind of like a pyramid though. And so if we look at the net of a cone, what we have here is we have this is the base of our cone. And then if we unfold that curved part, we actually get an area of a sector. And remember that the relationship between the area of the sector, let's just call this X, this area of the sector right here, okay? That's the area of our sector right there. And it might be a little confusing with the X in there, but so the area of the sector compared to the area of the whole circle, remember there's the rest of the circle, is going to be in the same ratio as this arc length is right here compared to the circumference of the whole circle. And so we can actually use those ideas. If we go ahead and put in X for the area of the sector part, because we can easily find the area of the circle, the area of the circle, I'm just working on finding the area of this sector using that information, because we can find the area of that base right there. That's just pi times radius squared. But what do we do for this? Well, we set up that ratio. And the area of this entire circle right here is pi times L squared. Because see, right here, that is your L, that's your slant height right there from this figure. Let's see if I can get a different color here. So this L right here is this same thing right there. And so the area of that whole circle is pi times L squared. The arc length is this part right here. And remember, that is the circumference of this whole entire base. So that arc length is really this whole thing right there, which is really just the area of that base, which is pi times, or is the circumference of that, so it's 2 pi r. And then the circumference of the whole circle would be 2 pi L. So now we can actually do some math and multiply each side to solve for this variable right here by multiplying by pi times L squared. Pi times L squared. And now what ends up happening here, it's kind of interesting, is these cancel out, of course. And our 2 pi's cancel out. And one of the L's right here is going to cancel with one of those L's. So the only thing you have left here is an R and a pi and an L. And so what we have is pi RL is what x is equal to. So x is equal to pi RL. And that's the part of that's the area of that sector. And then to find the surface area, we just add that with the area of the base. So this shows you that worked out a little bit more detailed again. But the surface area then is the area of the base, so that's capital B, pi r squared plus pi RL. And that L, remember, is your slant height. And you add those together and you get your surface area. So it's really not too bad. I just kind of wanted you to see where we were getting that information and why. So let's calculate the surface area and lateral area of this cone. So my surface area is equal to the area of my base, which is pi r squared. And I'm going to add that with my pi RL. So I'm going to take and put in my radius right here. And I'm going to put my radius and slant height in the other. So this would be pi times my radius, which is 7, times my slant height, which is 11. And that's going to be my lateral area. And I'm going to add that with pi times 7 squared. So again, this is our lateral area if they ask for that separately. And so our lateral area is 77 pi, and our base area is 49 pi, and we can add those together for our surface area. And we could give the exact answer is 126 pi units, and this is surface area, so it's units squared, or we could give it approximately equal to 395.84 units squared. So it's not too bad. Hopefully you can work your way through that. I'm going to have you try this one on your own. It's really similar to the one we just did. The only thing is you are not given this slant height right there. But notice you have this right triangle, so you should be able to calculate that using the Pythagorean theorem. So go ahead and try that and then check the notes later to see if you've done it correctly. We'll try one where we work backwards here. It says the surface area of a right cone is 453 units squared. The radius 11. Find the slant height. Okay, so again, your surface area is the area of the base, which is pi r squared, plus that area of the sector, which is pi RL. So now plug in all the things you know. We know the surface area is 453 equals pi pi times my radius squared, so 11 squared, plus pi times 11 times L. Again, I'm trying to find the slant height right here. So now this can get kind of tricky because some people want to add the pi, or the 121 pi, together with the pi times 11 times L, but you can't do that. So what we're going to do here is we actually have to subtract 121 pi from each side. So when I take 453 and subtract 121 pi, or 11 squared pi, whatever you want to do there, we get 72.867, so 87, and that is equal to pi times 11 times L. So now I'll divide by 11 pi. Now, I know some of you are probably not remembering this, but if you're going to divide by 11 pi, that needs to go in parentheses so that it divides by that quantity. So now when I take 72.87 and I divide it by, don't forget parentheses, 11 pi, that gives us a slant height of 2.11. And that was in just units. So we did one where we worked backwards. The last thing we're going to talk about is combining surface areas of this solid here. And this is kind of like other figures that we did areas, flat two-dimensional areas of, we had to add them together. The thing that's kind of different about this one is to find the surface area, you are going to take and find the surface area of that cone and the surface area of that cylinder. But notice, this is not on the surface, that's on the inside. So you're going to have to take away that base right there, and you are going to have to take away that base right there. So let's start working this out. We'll start with the cone. So we don't have the base. It's normally the area of the base plus pi r L. So we're just going to have pi r L, or pi times our radius, which is 2, times my slant height, which is 7. That will calculate this surface area. Now let's work on the cylinder. I still have one base, so I have pi times my radius squared, so 2 squared, and then I normally have the area of the base times 2, but I just have 1 because the other one's, remember, hidden. And then I have to add that with 1/2 the perimeter of the base times the height. So now I am going to, this is going to be, oh, I didn't fill in the perimeter, so we'll go ahead and do that. Pi times 4 times 1/2, and the perimeter, remember, is the circumference, so it is 2 pi times my radius again, times the height, which is 5. So now, calculating my surface area, I have 14 pi plus, now I have some other things like this 1/2 and the 2 cancel out. So now I get 4 times, oh, this is a plus in here, sorry. So I have 4 pi plus, then the 1/2 and the 2 cancel out, 10 pi. So adding these all together, surface area is 14, 24, 28 pi inches squared, or approximately 87.96 inches squared. All right, I have one for you to try this combination of these two figures, and then you can check the notes to see if you've done it correctly. But that is the end of 12.1.